I think one of the age-old human questions, perhaps going back to the beginning of humanity, is, are we alone in the universe? And that maps directly into, why are we here?
We're going back to the dawn of the solar system. We're looking for clues as to why Earth is a habitable world. This rare jewel in outer space that has oceans, it has a protective atmosphere. We think all of those materials were brought by these carbon-rich asteroids very early in our planetary system formation. And of course, the biggest question, the one that drives my scientific investigations, is the origin of life. What is life? How did it originate? And why was the Earth the place that it occurred?
4, 3,
Launching
2,
in 2016
1.
seemed like the highlight of my career at the moment, but it was really just the beginning of getting us to this incredible world, this small asteroid named Bennu. It's a stunning celestial object, and its shape is particularly intriguing. It literally is a droplet made out of rock, gravel, and boulder that are barely held together by their own microgravity. And it was amazing to have our spacecraft visiting this celestial neighbor for over 2 years. We believe that we're bringing back that kind of material. Literally maybe representatives of the seeds of life these asteroids delivered at the beginning of our planet that led to this amazing biosphere, biological evolution, and to us being here today to look back on that amazing history, to think about where did we come from?
3, 2, 1. And liftoff, OSIRIS-REx.
Before we get into the action though, tell me, Jim, what are you most excited about?
Lauren, it's the masterpiece of engineering we have here. Just think about this. In 50 years, we've gone from bringing things on the moon back with crews to all robotic sample return for science that's literally beyond words. It's sublime. So we can't wait to see what we're going to learn.
We cannot wait.
Yeah, good morning, Lauren and Jim. It's already been a very bright early morning for all of our team members involved in this mission. Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft.
Approximately 1 minute to release.
Stay with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission.
30 seconds.
30 seconds. We'll be coming to wake 1 on a move, then cold open, then camera.
Seconds.
10.
7 more. 6, 5, 4, 3.
Stand by, cold
2,
open.
1.
You're looking at live pictures of the sky above the Utah Test and Training Range. In less than an hour, a 4.5 billion-year-old piece of the ancient solar system will be landing here in the desert. This is live coverage of NASA's OSIRIS-REx sample return.
Very clear skies this morning as well. As we were actually driving out, I saw a shooting star, a meteor, and in just a few moments, the SRC itself will be streaking across the skies as we begin to track it. Our high-altitude plane is up in the sky, ready to take images in the infrared of our SRC, and we are here, ready to go to cover all of today's mission events. I'm going to be right here with you all throughout the process as we get closer to that entry, descent, and landing. Just a few moments ago, we heard the helicopters take off from here to head out to Wig just at the edge of the landing ellipse.
I am on the edge of the landing zone that we call the ellipse. It is a huge landing zone that is larger than the size of Rhode Island. And behind me are the helicopters that will be taking those recovery teams to the capsule once it lands. Now, these teams are prepped and ready to go. We're just waiting for that capsule to arrive.
As the SRC approaches the edge of Earth's atmosphere, we are just moments away from the world's largest ever asteroid sample return. Jim, what are you feeling right now?
I am literally tingling all over with exhilaration. This is a small step for a capsule and a giant leap for science.
It really is, and if that's one thing we can impart, that is it. This is a huge, huge milestone, a great achievement. So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment. Let's turn it over to our mission commentator, James Tralie, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. This is 13 minutes of crazy descent, punishing deceleration of our spacecraft, starting at 27,000 miles per hour when it enters into Earth's atmosphere, and eventually slowing to a leisurely 11 miles per hour as it descends and lands on the Utah Test and Training Range.
Recovery operations, helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. We're about 20 seconds away. You see the team at Lockheed now, all standing, ready on the edge of their seats. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EDO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high-altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. A phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah test and training range just a little bit further to the east.
EDO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high-altitude plane searching for that SRC. You can see it faintly on your screen there. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. And as I mentioned before, that will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah test and training range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation, but that is at 102,300 feet. And a side note, at this time, 8:44 a.m. Mountain Time, the OSIRIS-Apex spacecraft is at its closest approach to Earth. That will be on to its extended mission visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. Next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time. That will be at around 5,000 feet elevation. We continue to track with our high altitude camera here.
EDO milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle colored parachute, just a delight, a sweet delight to see. in our sky here over the Utah Test and Training Range. And now this is like a marathon runner savoring that last lap here as we approach the finish, that landing in the Utah Test and Training Range.
SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system. And the team can now breathe an immense sigh of relief. We now have the sample return capsule, the SRC, containing pieces of the asteroid Bennu. You see the reaction there just moments ago as they got that sample back on the ground.
Yeah. Looks good, huh?
Shield down.
Yeah.
Shield down, sitting straight up.
Parachute right next to it. We did it.
Not even tilted over.
Did it.
Not even tilted over.
Yeah.
Beginning to install the covers.
Standing water.
Beautiful.
Water safety huddle down. OSIRIS on 3. 1, 2, 3.
OSIRIS.
Congratulations to the OSIRIS-REx team. You did it. You designed it. You built it. And you carried out the first mission to collect a sample from an asteroid. And after a 2-year journey, it has touched down at the Utah desert. It brought something extraordinary, the largest asteroid sample ever received on Earth. This mission proves that NASA does big things, things that inspire us, things that unite us, things that show really nothing is beyond our reach. It wasn't mission impossible. It was the impossible became possible.
Well, OSIRIS ended just like it began. Absolutely picture perfect. I mean, I actually think I'm dreaming. I don't believe it. I don't believe it. The capsule was feet from a road. It just stuck the landing. It landed and didn't move. Didn't look like it was spinning whatsoever. Very, very straightforward recovery operations. Absolutely unbelievable. So thank you to everybody. The team has done an enormous job. This is what happens when you practice, 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 and practice. Everything goes perfectly. Couldn't be more proud of this mission, the team, military colleagues out here that have been with us every step of the way have been absolutely wonderful hosts, wonderful support. I'm gonna kind of miss this place actually. I'm kind of settled in here, and it's got a real charm once you get to know it. So thank you, Utah, for being our landing ground. Of course, my family, Kate, Xander, Griffin, wouldn't be the same without you guys here. It's been an amazing journey. My boys have grown up with the dad is the PI of the flight program on NASA, and that's no longer true. And I'm also really excited that we handed off and passed the torch to the next generation. I believe the divert maneuver went exactly as according to plan, and OSIRIS-REx is on its way to Apophis for the next chapter of this fantastic journey. And I cried like a baby in that helicopter when they told me that parachute had been spotted. I tell you what, that was the end of a long, long day. We've been up since about 1:30 this morning with spaceflight activities and everything. We can't wait to see how they're doing over in Avery. Hopefully they got that capsule nice and secured and on its way. There we go. Looks like they're getting ready to get to that back ship and see what the treasure looks like inside. So best times are ahead of us. I always feel that way. We're going to get in that canister. We're going to feel that tag sample. We're going to see those samples of Bennu, and we are going to rewrite the history of the solar system with the material that we brought back here. Thank you.
The doors are now open. We're entering into the clean room, and that SRC is about to be moved off onto our clean room fixture. This is why we do science, right? To get these kinds of samples, every piece of dust and grain inside that sample return capsule is a PhD thesis waiting to be written. It's a new discovery waiting for us about the origins of the solar system and our place in it. And the vast majority of that sample, more than 70% of that sample, is actually going to be stowed away for future analysis. We did the same exact thing with the Apollo missions when we brought back rocks from the moon. A large quantity of those rocks and dust from the moon our astronauts brought back were stowed away for future generations with the expectation that our technology will continue to improve and improve and improve, and then we'd be able to ask questions that we couldn't even begin to fathom. And now the same thing we'll be doing with the OSIRIS-REx samples that we brought back from the asteroid Bennu. A lot of these will be opened up 50 years from now with scientists who are yet to be born, asking questions we can't even begin to imagine.
Wow, don't be afraid to clap or cheer. Today is a celebration. Welcome to the much anticipated OSIRIS-REx sample reveal.
So 7 years, almost 4 billion miles of a journey throughout the solar system. Now back, the sample return capsule landed in Utah, right on the money. It was a picture-perfect mission. It's a feat of engineering. So, you ready to see the results of the mission? Take a peek.
Rocks tell you a story, right? And it's the story of Bennu and the history of the solar system that I'm most excited to unravel with the science program. And when we look at the materials, these clay minerals, these carbonates, you had a lot of water moving around in the early solar system beyond what we really expected from our meteorite investigations. You know, when we look at meteorites, we think water moving in very tiny scales, but I imagine a world right at the beginning of the solar system, right in that protoplanetary disk, where you had a lot of ice and a lot of rock and metal and carbon, and radioactivity started heating these things up, and you got massive circulation, what we call a convecting ball of mud, hundreds of miles across. And it's in that environment that I imagine these carbon atoms going through the first stages to the origin of life. And to me, that's the greatest mystery that we're facing right now, is like, how do you go from a ball of mud to something that's alive? Like, what happens when you make that transition? And the deepest desire is that we're gonna make some progress in trying to figure out, what is it? Why is it that we're here, we're alive, we're conscious in this universe? It's such a gift that I hope everybody really stops and thinks about it every once in a while, no matter what your problems are in everyday life. The fact that you're alive and that you're aware on this beautiful planet is something you should be grateful for every day. And that's really where I hope my imagination takes everybody.